talk a bit about like higher dimensions. Everyone knows. Hey, what's up, Facebook world? Let's just talk a bit about like higher dimensions. Everyone knows about, well, one dimension that is 0 dimensions is a point. There's nowhere to move. One dimension is a line. 2 dimensions is the Cartesian plane, x and y. 3 dimensions is x, y, z. Okay, so what happens when you get higher? Well, there's no way to draw it. You can draw a hypercube. You basically draw 2 cubes. So like when you draw 2 cubes, you draw 2 squares and then connect the vertices. Well, when you draw a hypercube, you draw 2 cubes. This is going to be really bad. But basically you do something like that, where you draw 2 cubes and then you connect them all together. The picture on the book does a much better job doing that. This book is also by the guy Matt Parker. You're probably familiar with his YouTube channel Numberphile. The Riemann zeta function, which is actually something that I'd made another video on for Pi Day, where I talk about infinite series. This book is like a buffet. You can go through and you can taste, oh, I want the hors d'oeuvres, I want the filet mignon or the steak, or maybe you just want to skip right to the dessert, or maybe you just want a Mobius loop or a donut. Yeah, these things are crazy. Yeah, like let's start with Newton's law. F equals ma. Force equals mass times acceleration. To each point P in a fluid, Euler produces following equations, which, when combined with the incompressibility equation above, describe the motion of the fluid. So it's the change in u. This is a derivative. It's a partial derivative of u with respect to x over the derivative over the change in time, plus. Now this comes from the product rule in calculus, plus partial y, partial u, x, partial y, plus mu y. Now, funny story, when I was at UMass Amherst, I tutored differential equations, and it turned out to be a really good experience because I was one of the only math tutors who signed up for it, and so everyone would come to me, even if they were like sophomores, or I even tutored like other seniors. But there's nothing like teaching something to help you learn how to do it. Okay, so you get basically all these partial derivatives, and I don't know if you can see it in the book, but each of these is a function of like an x and a y and a z. And so these are the equations of fluid motion to allow for viscosity. So each point P in the fluid produces the following equations, which when combined with the incompressibility equation describe the fluid's motion. So there's 3 equations. Well, so this is like a 4-dimensional function, x, y, z, and t. So the 3 dimensions, and then time, or you might hear space-time, right? So these are all the partials with respect to x. These are the partials with respect to y, and these are the partials with respect to z. Yeah, so, well, there's a lot in here, but like I just wanted to show also, I know this is getting really long, how that connects to machine learning, because pretty much everyone knows like the regression model, y equals mx plus b. When you get higher dimensions, you get multiple linear regressions. And you get y equals x, or beta 0 plus beta 1 x1 plus beta 2 x2 plus blah 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 plus beta p xp, and then the partial derivatives, partial y, partial x1, it's going to be, well, the derivative of beta 0, which is a constant, is beta 1, right? And then all of these other things are just treated as constants. So the coefficient of a linear model is equal to the partial derivative, or the change in the function at when the input changes. Because that's basically what that's what machine learning is. It's finding patterns and mapping inputs to outputs. So like, you know, before ML, mathematicians had to come up with these models like F equals ma and then test them out in scientific experiments. But with computers, the computer can write the code for you. Yeah, anyways, hope y'all have a good weekend. I am just doing some research, you know, learning, just kind of gathering my thoughts and remembering what I already learned and thinking about how that could apply to starting another business, doing consulting, or just sort of getting like maybe like speaking engagements. Thanks for watching. Hey, what's up, Facebook world?